Welcome back to the shop. Today we're machining some wheel spacers out of titanium. And titanium is a weird material to machine. It's kind of like stainless steel. It doesn't disperse the heat very well like steel or aluminum, so the point of your tooling gets very hot, and you have a localized heat wherever that point of tool is. So if you aren't feeding into the material very fast, very hard, then you get a localized hardening in the material, and once that happens, now you're really struggling because the tool can't bite into the material. It wants to just skate over top of it, and it's especially noticeable if you're using a high-speed tool steel instead of carbide tooling. So doing stuff like drilling that hole out in the center, if you're using just a regular high-speed steel drill bit, man, it is tough. And especially as the diameter gets up, and because as the diameter gets up, then the tips, the material is traveling at a faster rate than it is in the center, and so the heat just goes up and up and up. So you have to use flood cooling with it to really machine it. Stay away from the high-speed tool steel when you can, and use carbide. Flood cooling all the time. Your feed rates are up, and your speeds are way down. And it's very springy and stringy, so as you're machining you get these long spirals coming out and they don't break. Now I'm sure there is specific tooling if you're in a production shop with $100,000 plus machines and unlimited tooling budgets, and the customer's paying for it. You're buying special chip breaker tooling probably, and special coatings and everything else from the manufacturer. I'm just a home guy in my shop at home, so I'm making do with what I've got. And so I said it's very stringy, the chips come off in long spirals, and it's very springy, which means that sometimes you have to do a couple of finish passes on it to get it to final size, because it's soft. It's an interesting material. It's stronger than aluminum, comparable to steel in some cases, but it has a high bending modulus, so it's springy is the only word I can think of to describe it. So one of the tricks that I've learned making these are wheel spacers, and I've made them before. They turn out really nice. The finish is actually really good on them, considering how difficult it is to work with this stuff. One of the tricks I've learned for drilling is to use masonry bits. Masonry bits are carbide tipped, and they really actually work quite well. You try drilling this with a high-speed steel, and it just screeches. It's just screaming as the high-speed steel is trying to cut the material. But you use those carbide tipped masonry bits, and which sounds ridiculous, but they just drill through it quite nice. You still get a little bit of chatter, but whatever, it works really well. So we'll show you a little bit of machining on the part that we're working on. I'm making another one almost the same as this one, and you'll see the string. Hopefully you'll see the chips coming out in big long spirals. So there you go. There's a couple of titanium wheel spacers. You know, I was able to hold tolerances plus or minus a thou, or maybe plus or minus 2 thou. Not bad for a small Chinese lathe. And you know, if it was anything more critical than that, I guess you'd probably have to leave them a little oversized and then go at it with a, you know, file on the lathe and sand it down to get your final dimension. You might get a smoother finish too, but that's not bad at all. That's a really smooth finish for most things. So there you go. That's it.